Hi, my name is Connie Francis Arafa, and I'm one of the lecturers at the junior college, and I teach chemistry. And here's one of the really wonderful labs of the chemistry department. It looks honestly like from a science fiction movie. Anyway, I'm here, for example, today, to speak about the various different researchers that we have, in our case, in the chemistry department. And in front of me, I have Miss Maria Magro, who is studying for her doctorate. And that's really, really tough. Anyway, so she's going to tell us, for us lay people, okay, what research is. So in layman's terms, because I'm certain a lot of the people in our audience, all right, and the kids there, want to know really what research is in layman's terms.
I think that research is in our everyday life because anything we use, any product, any process, it was part of a research process. It is also the creation and answering of questions, and it could also solve problems which could make our lives for the better. Another thing about research is that innovation, creativity, and even inspiration can come together to create new knowledge. But also, any existing knowledge that we already have on our hands can be used and tweaked to create new ideas.
Oh, that sounds really interesting. Now, for the viewers out there, we'd like to know, what is your research about? I heard it has to do with graphite. Isn't that the thing that's found in pencils?
Yes, but it's not on graphite per se. It's basically on graphene oxide, which are small flakes that we cannot see with our naked eyes. And these are basically, they can be prepared from graphite, which is the tip of the pencil that we use to scribble on a piece of paper. Graphite, it is made up of carbon as an element, and the atoms of carbon are arranged as layers on top of each other. If we take one of these layers, that would be graphene. And that one layer of graphene, if we introduce to it atoms like oxygen, it becomes graphene oxide. What is fascinating about graphene oxide is that if we place it on a porous structure like a polymer, which has a lot of pores, like for example polyurethane, which is used to make the dish sponge, or even polysulfone, which is another type of polymer, it can remove the salt, the sodium chloride, from seawater to produce water that is fit for drinking. Now, the research doesn't involve only the preparation of these chemicals and materials, but we also need to make sure that these materials are good enough for the experiments that we do. And in this case, we need to use special machines. For example, the first one is a very powerful microscope. We use the scanning electron microscope, which is a very powerful microscope, and this shoots electrons towards the sample to get an image of the sample. Other machines, for example, use X-rays. What are X-rays? These are also found in hospitals and even in other clinics. And what they do is that these X-rays interact with the sample, and eventually we can get the composition of the material, like what atoms are present, the type of bonds that are present between atoms, so that we can get a nice idea of what the sample is made of.
Wow, that really sounds like some complicated stuff, but it sounds really, really exciting, honestly. Well, I think we'd all like to know, what motivates you to do this research?
Well, since my research is about desalination, that is the removal of salts from seawater, and since our country is in a way deprived of fresh water and we rely a lot on reverse osmosis, which is a very powerful process to remove salts from seawater, our country would benefit because this idea uses much less energy than the traditional desalination systems.
Oh, that's true. I mean, without removing that salt from the water, I mean, we have lots of problems. Imagine us drinking salted water. So I think that if you can make it with less energy, that's even better.
Exactly.
Okay, well, I think you answered this question already, but as I said, we do see how beneficial your research is. So, but in your opinion, are there any other benefits of your research or other ways that it's important to us?
Yes, because apart from using lower energy, I think the world as a whole can benefit, because less energy means a lower carbon footprint, which I'm sure you've heard about.
Yeah, as I said, we all have to kind of take care of our environment. So maybe you're one of the people
Exactly.
who are going to help us do that. Thank you so very
Thank
much,
you.
and we wish you the best of luck with your research.
Thank you.
Thank you. So the next person that I have in front of me is another researcher. His name is Dr. Noel Vela, and he's also a member of the chemistry department at the junior college. Now, before we ask him about his research, because I think it's a bit exciting, all right, could you tell us, Dr. Vela, could you tell us in layman's terms, you know, for the ordinary people, okay, what is research?
Well, research is basically the search for knowledge. So basically the idea of doing research is to try to fill in knowledge gaps and to get new knowledge to build upon that. So basically the aim, at least the way I see it, is to use innovative techniques, also to create new techniques, and basically these techniques can then be applied to already existing knowledge in order to widen our perspective of what is required and how, hopefully, we improve things around us.
Oh, that sounds very interesting. Now, I heard that your research is about sharks. You mean, like, for example, the ones in the films, like Jaws? Should we be afraid? So, yeah, what is your research about?
Not that much. Well, first of all, if we were to focus on sharks, it's not something that we have to worry about.
Oh, phew.
Okay. The numbers of sharks are really low. For sure, we kill more sharks than we get attacked by sharks. So we're basically diminishing their populations to a very small population sizes that some of the species are close to getting extinct. My research basically focused on the use of these organisms, including sharks, but not just sharks. The research I'm going to speak about was part of my postdoctoral research, where genetic techniques were used in order to get to know more about the species, mostly fish species, including sharks, that live around the Maltese Islands. Basically, this research involves, first of all, to work with fishermen and to work both full-time fishermen that go fishing and earn a living from fishing, but also with hobby fishermen or fishermen that go by the seaside to fish. We collect fish from there, so basically these fish are already dead, and from these fish we extract, we take up a very small piece of tissue. Here we're speaking of milligrams of tissue, and we do like they do in forensics. That is, we use this tissue, we extract the DNA from the tissue, and then we study small sections of the DNA by amplifying this DNA, and we use these sequences as sort of barcodes in order to discriminate between the different species. Some of the species are also the sharks that you're mentioning. So we can discriminate species, even shark species, from each other.
So, okay, so not just sharks. So what other type of species of fish do you study?
Well, various species of fish. Well, basically the project looked into over 200 different species around the Maltese Islands. Some of them do come from the groups of sharks, but there we're speaking just of a few tens. But then the rest were other fish species. I mean, the coastal ones. If you go snorkeling, you will see them. I mean, painted comber, sea bream, and so on. Now, the importance of, because one might say, why do you need to use genetics to identify these fish, while going through the hassle of doing these molecular techniques in order to identify species? One of the problems with not just fish, but other organisms is that sometimes species look very similar to each other. And in order to be sure that what you're seeing is the species that you think it is it's very good to have these, well, so to say, universal codes, we're calling them barcodes, that can be used to tell one species from another. Because if a species has a specific barcode or a specific sequence of DNA, it will be the same not just for Malta, but from other places even around the globe. So the use of this technique is not just to be a localized study, but also the data generated from these molecular techniques are inserted into international repositories, and these can be also accessed by international researchers. So at the end, all this knowledge gained from the local biodiversity is integrated with other knowledge that we gain from also foreign researchers to increase our knowledge about the species that we're studying.
So in other words, it's kind of classification on level of DNA. So that's really, for example, something very specific.
Yes, it is basically, that's right, it's the classification of species, not just fish, but it can be used for all other organisms, using their DNA sequence. So using molecular techniques in order, or a molecular sequence in order to be able to discriminate between the different organisms.
Wow, that sounds like great stuff. Now I bet our viewers would like to know, well, what motivated you to do this research? Is it the love of fish or other things?
I think both. The love of fish, yes. I live close to the sea. I've been going to the sea, my whole life, going fishing and so on. But as a biologist, I was more intrigued into the use of the DNA and the use of new technologies, because even with DNA, the technologies are changing all the time. From 1 year to another, techniques evolve quite rapidly. And basically, the use of these techniques helped me to better understand the biodiversity that I was seeing when I was a child, and now I'm able to answer certain questions that I think we have more rigorous grounds upon which we can arrive to certain conclusions.
That sounds fantastic. Now, last thing I'd like to ask you is, in your opinion, how is your research, important or beneficial?
Well, this research is important because to identify species is one of the most critical aspects that we need in order to be able to protect. Because you can't protect something that you don't actually know. One of the problems with fish, for example, and even shark species, because we were mentioning sharks earlier, is that when they are caught, they are placed into general categories. So if you catch something and you just say it's a shark, but what is the life history of that organism? How does it grow? How long does it take to age and to reach maturity? All these organisms have different life histories. And in order to be able to pinpoint the best conservation measures towards a species is to first identify it. Because if you don't identify it, you can't even come up with good mitigation measures in order to conserve it.
Oh, that is very interesting. And as I said, thank you for your research, because I think you're going to be helping us all out, figuring out that, a fish is not just a fish. It's much more complicated than that. Thank you very much for joining us today. And thank you, viewers, also for joining us. I hope that you learned something about, the various different researchers that we have. And maybe one day you'll be a researcher too, or we'll see you at the chemistry department. So I do hope I will see you here. Have a wonderful day. Take care.